welcome to all participants. We're going to give our colleagues a couple more minutes to join us, if you'll bear with us. Thank you. Okay, it's the top of the hour, so I want to welcome all participants to this webinar hosted by Verra. We're going to allow more registrants to join we give them a few more minutes, say 3 more minutes for more participants to join. So if you'll indulge us, we'll begin momentarily. Thank you. If we'll just give more registrants 1 more minute, we'll begin in 60 seconds. Thank you. Okay, we'd like to welcome you to this webinar hosted by Verra. Today's webinar looks at the VCS Jurisdictional and Nested REDD, or the acronym JNR framework. I'd like to remind you that this is part 2 of a 2-part in-depth training for VVBs on JNR. Part 1 was conducted last week, and the recording thereof will be shared with all registrants together with today's session recording as well as the PDF version of the slides. Kindly note that today's session comprises of 3 presentations with a body break in between them. My name is Leo Long. I'm going to be emceeing, and I'll introduce you shortly again to your presenter. Salvador, if we can go to the next slide, please. Thank you. So before we get into the content of the presentation, I'd like to go across a couple of house rules. Kindly note that the session is being recorded and therefore your continued participation is taken as tacit agreement to being recorded, with the intention obviously of sharing the recording with all registrants after the presentation. You are welcome to turn your camera on if you wish to. Kindly note that all participant microphones have been muted. However, we do welcome your engagement, specifically requesting that you post questions to the Q&A function. As I mentioned, we request you to post your questions to the Q&A function and we will endeavor to respond to all questions during the session. However, for those questions not answered during the session, we'll encourage participants to please send their questions directly to the presenter, whose contact information will be shared towards the end of the presentation. In terms of the QA function, kindly note we've enabled the upvote function. So if there's a question you feel is pertinent and you'd like us to focus on that, please use the upvote function to elevate that question. Next slide, please, Salvador. That being said, I'm mentioning Salvador repeatedly. I'd like to introduce you to your presenter again. Salvador is the Manager REDD Technical Innovation here at Verra, and he's going to be taking us through the content of today's 3 presentations. With that, I'd like to jump to the next slide, which is the agenda, Salvador, and then pass it over to you to take us through. Thank you.
Thank you, Leo. Good morning or good afternoon, everyone. Thank you for joining us again. This is episode 2, session 1 of the JNR training for BBBs in particular. In this first presentation of today's session, I would like to outline the main requirements that the jurisdictional, that the JNR program, I would like to outline the main requirements that the jurisdictional forest reference emission level must meet to be acceptable for a JNR program. Now, as you all know, FREL is made up of 2 main components, the activity data and the emission factors. So I will then describe the requirements that these 2 components should meet under the JNR framework. And finally, I will briefly outline why, how, and when a jurisdictional FREL must be reassessed. So just as a reminder, this 2-part webinar seeks to provide an in-depth training for BBBs on the requirements of the JNR framework. By successfully completing this webinar, BBBs can satisfy section 3.2.1.3 of the JNR validation and verification process, which requires that BBBs, and in particular the lead auditors, must complete a JNR training provided by Verra. So this is part 2 of such training. As you might recall, part 1 was presented last week on the 17th of October. So let's enter into the matter. As per the UNFCCC definition, forest reference emission level, or FREL, as we usually call it, is a reference level or benchmark that quantifies the volume of GHG emissions coming exclusively from deforestation and forest degradation in a country under the UNFCCC context, or in a jurisdiction in the context of the voluntary carbon market. Now, to be comparable, these emissions must be expressed, all of them, in terms of tons of CO2 equivalent per year. And they should be quantified over a set reference period, like the one that we are illustrating here. And the FREL, this reference level that is shown in the dotted line, is then used as a reference or baseline, and against which the performance and success of activities aimed at reducing emissions from deforestation or forest degradation can then be assessed. Now, in the particular, that's the UNFCCC definition. Now, in the particular context of the JNR framework, the jurisdictional FREL is also used for determining the baselines of the nested projects, and also the reference emission levels of those lower level programs that are nested within the jurisdiction. And by means of the allocation, this is achieved by means of the allocation approach, in which a fraction or portions of the jurisdictional FREL are assigned or are allocated to the nested projects and to the nested lower level programs. In turn, those portions of the jurisdictional FREL that are allocated to programs, nested programs and projects, and then these are used to construct or become the reference the reference level of these projects or the lower level FRELs of these nested programs. Now, and it becomes they become then the benchmark of reference level against which the results achieved by these nested projects and programs can be compared in order to determine the volume of GHG emissions reductions that their activities have achieved over time. And now, let me remind you that this applies only to scenario 1 and scenario 2 only, because in in a scenario 3 JNR program, we don't have nested projects or programs. Now, the jurisdictional, let me now list a few of the requirements that the jurisdictional FREL must meet. First, a jurisdictional FREL is constructed as the annual GHG emissions averaged over the 10 previous years, which is what we call the historical reference period, this 10-year period. Just a little note here, the JNR requirements, the JNR documentation states that the historical reference period should be between 6 to 10 years long. But we have to update this part of the JNR documentation in order to make it consistent with the latest version of the VCS requirements that state that the historical reference period for these sort of projects or programs should be 10 years. Now, the methods, data, and results of the jurisdictional FREL, this one, must be consistent with those that the country has used in their submissions to the UNFCCC. Particularly, these values must be consistent with the national GHG emissions inventory. Now, as we can infer from this graph, the extent and rate of deforestation or forest degradation in due case vary over time. For this reason, this reference level cannot remain static indefinitely, but has to be updated to take these changes, these variations over time into account. However, at the same time, collecting the data and information necessary to construct the FREL is costly in terms of time, sometimes in terms of effort, and also in terms of money, so that the FREL cannot be updated too often. So as a sort of compromise, the JNR states that once the FREL has been validated and verified, it will remain valid for the following 6 years. This is what we call the validity period. Once again, the JNR documentation states that the validity period of a jurisdictional FREL should be between 4 to 6 years, but this needs to be updated again to make it consistent with the latest VCS requirements, which state that it should be exactly 6 years. After that 6-year period, a new FREL will have to be constructed. And the JNR also imposes the condition that the new FREL, the revalidated or newly constructed FREL, cannot be higher than the previous FREL, because this would mean that the REDD activities that you were implementing in this jurisdiction have not been successful at all, and maybe it have made things even worse. Secondly, the JNR also imposes the condition that the jurisdictional FREL must clearly disaggregate those emissions coming from deforestation from those that come from forest degradation. And ideally, or to the extent possible, those emissions coming from planned deforestation must be kept or recorded separately from those that come from unplanned deforestation, and the same for emissions coming from planned degradation and unplanned degradation. Particularly in order to avoid double counting of these different emissions coming from different activities. Now, there are also a few particular conditions that the jurisdictional FREL must comply. First, those emissions stemming from large-scale but infrequent forest loss events that might have occurred during the historical reference period, but that are unlikely to happen again during the FREL validity period should not be included in the FREL. This is commonly the case of large-scale forest loss events that were caused by disasters associated to natural phenomena such as landslides or hurricanes or so. And by large scale, we mean over 1,000 hectares at least. And in those cases, the area that was associated or was affected by those historical losses due to natural disturbances should be identified and excluded from the calculations for FREL. On the other hand, however, the FREL can include those emissions that the emissions from large-scale forest loss events that did not occur, were not observed in the historical reference period, but that are almost certain to happen in the future during the validity period. This might be the case of large-scale infrastructure works or projects that are known almost certainly that will be implemented in the jurisdiction, like, for example, large-scale infrastructure works that are already in the national development plan for which construction is underway, etc. And those emissions, those future emissions, can be included in the FREL as part of the planned deforestation component of the FREL. And finally, the GHG emissions encompassed in the FREL should not surpass the emission potential of the forest still remaining in the jurisdiction. I don't know if this is clear, but the thing is that, for example, it might be the case that you estimate the FREL over the historical reference period, and it amounts to, say, 100,000 tons of CO2 per year, for a total then of 600,000 tons of CO2 over the validity period of the 6-year validity period. However, perhaps in this case, in this particular jurisdiction, those 600,000 tons could imply the loss of 6,000 hectares of forest over those 6 years. But it may happen that in those jurisdictions, there remain only 4,000 hectares of forest. So, there are only 4,000 hectares of forest in the jurisdiction, but the entire FREL might amount to a volume higher than the one that can be stored in those remaining forests. In those cases, the FREL has to be adjusted downwards. Now, how the FREL should be constructed in general, not only in the JNR framework. The level of emissions that are observed over the historical reference period, this one, these are the emissions levels of each year over the historical reference period, these are the basis for calculating the jurisdictional FREL, which in this case is simply the historical average of these values. Now, these historical GHG emissions must be estimated separately for each of the activities, for each of the 2 activities that are encompassed in the FREL, in the jurisdictional FREL, deforestation and forest degradation. We will have to construct a similar plot, so to speak, for deforestation, for emissions coming from deforestation, and a similar one for emissions coming from forest degradation in the jurisdiction. Now, these GHG emissions are estimated by first estimating activity data in tons in hectares per year, the number of hectares that were deforested each year over the historical reference period, separately for each forest type or forest strata that exist in the jurisdiction. And these values have to be multiplied by what we call the emission factors corresponding to the deforestation, the transition of forest to non-forest, or the transition from pristine forest to degraded forest in the case of forest degradation. These are the emission factors, and multiplying this activity data times the corresponding emission factors for each of the forest types or forest strata that exist in the jurisdiction, and then adding them all together, we obtain the the GHG emissions coming from deforestation, in this case, over the historical reference period, and basically the average of these annual values yield the FREL for this jurisdiction in particular. Now, let's examine the two components of that are involved in the construction of a FREL. On the one hand, the activity data, as per the IPCC definition, activity data denote the extent of an anthropogenic activity that results in GHG emissions or removals during a given period of time. However, in our particular case, we will be talking about deforestation activity data, that is the extent of forested land that was converted to non-forest during a given period of time. And we will also be talking about forest degradation activity data, which is the extent of a forest, pristine forest, that was degraded over a given period of time. In both cases, the activity data are expressed in terms of hectares, number of hectares per year that were deforested or that were degraded. And then to construct the FREL, we would require a time series of annual activity data encompassing the whole of the historical reference period. At least we would require at least annual values, or at least biannual values every 2 years. A time series comprising annual or at least biannual values over the historical reference period to construct the FREL. Now, how activity data are constructed or evaluated? The JNR framework allows for activity data to be estimated using either of two methods or methodological approaches. The first one involves first constructing wall-to-wall forest cover maps that cover the entire jurisdiction at different points in time. For example, these are for a particular jurisdiction in Peru. It's a forest cover map for one point in time, for 1 year, and for a different year, later year. These maps only show forests in green and the extent of non-forest in gray. And by overlaying these successive maps, what we obtain is a land cover change map, which shows the locations where forests remain stable, the dark green colors, and also where forest was lost. By counting the pixels in each of these classes, we then obtain directly an estimate of the extent of deforestation between these 2 points in time. Naturally, the accuracy of the estimate of deforestation or forest loss that we obtain here is heavily dependent on the accuracy of the forest cover maps. Therefore, the JNR framework requires that the accuracy of each of these maps be evaluated, and equally important, the accuracy of the estimates thus obtained should be evaluated, and more importantly, these estimates must be corrected by applying the appropriate statistical procedures that are described in the methods and guidance document produced by the Global Forest Observation Initiative. In both cases, both the accuracy of the maps and the accuracy and bias correction of the estimates should be carried out by a statistical method that relies on the visual interpretation by expert interpreters of a set of sample points that are distributed across the jurisdiction using higher resolution satellite imagery, and following all the procedures described in this document or these guidelines. The second method that the JNR envisions for constructing activity data consists in not constructing wall-to-wall maps first, but directly applying the sampling procedure based on visual interpretation by experts on an extensive set of sample points distributed across the jurisdiction and using higher resolution satellite imagery. This is, again, say the boundaries of a jurisdiction, and then the little dot red and purple dots represent sample points distributed across the jurisdiction or the boundaries, and in each of those, a visual interpreter examines high-resolution satellite imagery to determine directly forest loss or forest permanence from one point in time to the next, and to the next, and so on. Using this sample-based methodology requires designing and implementing a number of various methodological elements or steps as directed by the methods and guidance documentation of the Global Forest Observations Initiative. This includes designing how the sample should be distributed, whether randomly in a stratified random design, and so on. The sample size, the number of sample points that should be examined, how each of these has to be classified by the interpreters, and how the interpreter's error or discrepancies should be addressed. And finally, how the data collected through this method should be statistically analyzed to come up finally with an estimate of activity data, the number of hectares that were deforested from one point in time to the next. Using either of these methods as the end result, what we obtain is an estimate of activity data, in this case, the number of hectares that were deforested for each year over the historical reference period. I don't know if you can read it, but the historical reference period in this particular case, it spans from 2010 through 2019. And using these methods, what we obtain is an estimate of the number of hectares, the area that were deforested in each of those years. It is repeated for each of the 4 forest types or forest strata that exist in this jurisdiction. And something that is crucial is that each of these estimates, activity data estimates, has to come with an estimate of the uncertainty of these estimates. This is also a crucial, having the activity data accompanied by an estimate of their accuracy or uncertainty. Now, the second element necessary for constructing the FREL are the emission factors. As per the IPCC definition, an emission factor is a coefficient that denotes the volume of GHG emissions or removals that result from one unit of activity. In our case, this would mean the amount of GHG that are emitted as a result of deforesting or degrading 1 hectare of forest. Naturally, emission factors vary between forest types, between forest strata, and also between activities. It's not the same amount of GHG emissions that come from deforesting 1 hectare of forest or degrading 1 hectare of forest. And there are at least 2 methodological approaches to estimate emission factors, but in the VCS in general and the JNR in particular, emission factors are estimated based on the change in carbon contents that are caused by the land use transition. For instance, in the case of deforestation, we will be looking at the difference in carbon content between 1 hectare of forest and the 1 hectare of the deforested land. In the case of degradation, we will be looking at the difference in carbon content between 1 hectare of the pristine forest and 1 hectare of the degraded forest, and so on for each land use transition that we are considering. Now, how we estimate the carbon contents in a given forest or brown forest land. These estimates of carbon contents must be produced for all the major carbon pools in the forest or non-forest land. In a forest land, for example, we have to estimate the carbon content, the amount of carbon stored in the above ground and below ground biomass. Also, the carbon content that is stored in dead wood and litter, and also in the organic matter stored in the soil. And the same we'll have to do to estimate the biomass content in the different parts of a non-forest or deforested land. The JNR requirements list the various methods and considerations and data sources that are admissible for estimating carbon contents in each of these pools. For the above ground and below ground biomass in the forest, for deadwood and litter biomass found in the forest, and also for the different different pools of biomass that exist in a non-forested land. In all the cases, the preferred method in general is estimating carbon contents by using data obtained in local plot-based field inventories. With a given number of conditions, the sample size must be at least 20 units per forest type or forest strata, and so on. However, it's often the case that in some cases, these field forest inventories or field inventories are not available or cannot be carried out, and the JNR framework also includes provisions for using data, default factors, or models developed elsewhere, provided they meet the requirements stated in the VCS methodology requirements or in the JNR requirements. So, but in any case, in general, the preferred method to obtain these estimates of carbon content in each of these pools is based on using data obtained through field inventories in the same jurisdiction. And as was also the case for activity data, the uncertainty associated to each of these emission factors estimates of each of these biomass estimates should also be evaluated. And the uncertainty in those cases where biomass data are obtained directly from field measurements, the uncertainty of those data or those estimates comes directly or can be calculated directly using the sample standard deviation. But in those other cases in which the data are obtained from the literature, from international studies or global data sources or so, some estimate of their uncertainty has to be produced based on different considerations. And in each case, all the major sources of uncertainty should be evaluated. In the uncertainty associated with each parameter involved in the calculations, the sampling uncertainty involved in the field inventories, and so on, except for the uncertainty associated to the direct measurements themselves. For example, you don't need to include, or the project proponent does not need to include the uncertainty associated with measuring the diameter at breast height of each tree, or with the use of the allometric equations. As a final result of all the calculations or the work involved in constructing emission factors, we will obtain a set of data like this. On the one hand, we will have biomass estimates of the biomass stored in each of the carbon pools existing in the forest. The above ground and below ground biomass, above ground and below ground dead biomass in form of litter or standing dead trees or lying dead wood, and so on. And for each of these components for each of these carbon pools, we will obtain an estimate of their biomass, and by adding up all this biomass contents, we will obtain the biomass estimate for this particular forest type. And then this is for this estimate is for this particular forest type. Then these biomass values or estimates have to be converted to tons of carbon stored in each of these in each of these carbon pools, or in this or 1 hectare of this forest stratum. This conversion from biomass values to carbon content values is carried out by applying a carbon fraction. Basically in rough terms, each kilogram of biomass or tree biomass contains about 40 to 50% of carbon. And so by applying this carbon fraction, we obtain an estimate of the carbon stored in this forest stratum. And finally, these carbon content values are converted to tons of CO2 equivalent by applying simply the ratio of molecular weights between carbon, the molecular weight of carbon and the molecular weight of CO2, which is about 3.6 times as large as the carbon contents. And that way, we obtain what would be the emission factor for this particular forest type. These values basically can be interpreted as saying that, for example, 1 hectare of this forest type in this jurisdiction contains about 292 tons of biomass, which in turn contain some 137 tons of carbon, which if this 1 hectare of this forest is cleared and all the biomass burnt out, this would lead to the emission of about 504 tons of CO2 equivalent to the atmosphere. Of course, for each of these estimates, we need also an estimate of the uncertainty associated with these values or these estimates. Finally, by compiling all these sort of results for each of the forest types or forest strata that are presented, that occur in the jurisdiction, and multiplying these emission factors times their estimated activity data and adding up all of them together, we obtain finally an estimate of the historical emissions over the historical reference period. In terms of annual values, which then will be averaged over the historical reference period to obtain finally the FREL for this jurisdiction. And finally, as we said, all these estimates of activity data, emission factors, and emission values convey a certain level of uncertainty, meaning this means that the real value of this is just an estimate, and the real value of emissions might be higher or lower than the estimate that we came up with. So to err on the conservative side, the VCS requires that the estimated historical GHG emissions must be conservatively discounted by applying a discounting factor using this equation. The discount factor, the DF, is a function of the uncertainty of the estimates, and I just included this table here to show the how these discounting factor values. These are the values for the discounting factor that has to be applied, and these values are a function of the level of uncertainty involved in each of these estimates. Basically, if the uncertainty of each of these estimates is lower than 10%, there is no discounting factor. The discounting factor is 0. But the value of this discounting factor increases with the increasing uncertainty of these estimations. Basically, what this equation does is to deduct the estimated historical emissions by the fraction of the discounting factor to obtain the conservatively discounted historical GHG emissions. And this way, by applying this discounting to the average obtained here, we obtain the conservatively discounted FREL for this jurisdiction, which is the one that we will be using or will remain valid for the following 6 years in this jurisdiction. And finally, now, as we said, the jurisdictional FREL cannot remain static indefinitely, but it has to be updated every 6 years to take into account the changes in deforestation rates, deforestation processes over time. And for updating the FREL, 2 things have to be considered. On the one hand, first and foremost, the activity data must be updated to incorporate the most recent data of deforestation or forest degradation, and the emission factors, the data, the field data or the data from the literature that were used to estimate the emission factors must be revisited. But perhaps during those 6 years, new, better, more accurate estimates of biomass contents or more field data have become available in the jurisdiction, and these improvements should be incorporated in a new, better estimate of emission factors. And also, in the process, the jurisdictional FREL can be broadened at any time. For example, if you want to include additional activities, perhaps the initial jurisdictional FREL only included deforestation, but now the jurisdictional proponent is now in a better position, and now can include also emissions coming from degradation, and then the FREL has to be widened, or it may be narrowed down when you can show that some carbon pool or some activity can be removed and without affecting the overall level of the FREL or GHG emissions. And I think that's all for this part. I think we have some minutes that we can devote to see if there are some questions in particular to these the topics that we dealt with here. We can spend, I don't know, 5 minutes or something to try to address some of these questions. Please place them in the Q&A box.
Absolutely. Thank you, Salvador. I see we've got one question so far. If you'd like to address that one live, Salvador.
Yes. So there is this question. It says, what happens if we apply a JNR project with the application of an existing FREL, which only takes into account deforestation? Should we include forest degradation to be eligible? No. The jurisdictional FREL might only include deforestation and only the GHG emissions, and more importantly, the GHG emission reductions that are achieved by reducing deforestation are taken into account. Any emissions coming from forest degradation are not taken into account because you don't have the reference to judge them against. Thank you.
Perfect. Thank you, Salvador. I want to invite participants, if you'd like to raise your hand and ask a question live, I'll give you that opportunity as well. So if there are any questions somebody would like to pose to Salvador live, I'll give you that opportunity now. Okay, Salvador, can I suggest we go to the last slide, please?
Yes.
Thank you. Thank you so much, Salvador. So this slide here provides the contact details for Salvador at the bottom of the page. And so any questions which were not addressed now during the Q&A, and if you have any specific questions you would like to raise with Salvador, he'll be more than willing to respond to your questions. Please email them to here. This email address is shown on the screen now. Also, the email address of Julianne Barodi, who is our Senior Director of Forest Carbon Innovation, is also provided and should also be willing to respond to any questions. We will now take a 5-minute body break, and then we will return to continue with the next presentation. As indicated earlier on, this session today is made up of 3 presentations, this one being the first, and after the break now we will continue with the second presentation of the day. So welcome you to take a few-minute break and return again to continue with the next portion. I think let's reconvene at about 8 minutes to the hour. Thank you.
Yes, thank you. We'll see you later.
Okay, welcome back. We will then carry on with the second presentation of this, the second part of the training on the VCS JNR framework. I'd like to welcome you to this second part of today's presentation, and we will dive right into the content. Salvador, if we can jump to slide 2. I'm going to give it over to you, Salvador, if you're going to take us through the agenda. Thank you.
Thank you so much, Leo. Thank you for coming back. So in this second segment, it would be a rather brief one. Basically, what I want to do is to describe the basis of the JNR allocation approach and how this allocation approach is implemented in practice to allocate portions of the jurisdictional FREL to projects and lower level programs. The allocation approach, as we will see, is based on modeling, a spatial explicit modeling of the risk of deforestation within the jurisdiction, and then allocating portion of the jurisdictional FREL, the one that we just estimated in the previous session, to the nested projects and programs. So you might recall that a key element of the JNR framework is carbon accounting nesting, as this ensures this carbon accounting the nesting of carbon accounting ensures that the baselines of the REDD projects and programs nested within the jurisdiction are fully aligned with the jurisdictional FREL. That is, the sum of the baselines of these projects or the FRELs of these nested programs, all of them add up to the jurisdictional FREL, no more and no less. Now, in the VCS JNR framework, the carbon accounting nesting is achieved by adopting what we call the jurisdictional allocation approach, in which the jurisdictional FREL is split into fractions or portions, which are then allocated to the projects and programs that are being implemented within the jurisdiction. And these portions of the jurisdictional FREL become the baselines of these projects or the FRELs of these sub-jurisdiction, so lower level programs. Now, there are different manners in which this allocation, this splitting of the jurisdictional FREL and this allocation or distribution among the nested projects and programs can be achieved. In the JNR framework in particular, the allocation is based on the observation that deforestation does not occur homogeneously across the jurisdiction, but instead, deforestation or forest degradation is more intense in some parts of the jurisdiction and less intense or even nil in some other parts of the jurisdiction. And therefore, we would like to incentivize forest conservation actions in those parts of the jurisdiction that are under higher threat. Therefore, in the JNR allocation approach, the allocation is proportional to the local risk of deforestation, so that areas that are exposed to higher risk of deforestation or forest degradation are allocated a higher proportion or a larger fraction of the FREL, as there will be a larger opportunities for climate change mitigation for emissions mitigation in those places, and this could lead to higher baselines and potentially to a higher number of carbon credits that can be issued. To apply this approach, what we need first is to assess the risk of the deforestation, and we assess the risk of deforestation and how this varies across the jurisdiction by looking at historical how deforestation across the jurisdiction has behaved or has been observed in the recent past during the historical reference period. Now, if you look or if you examine the JNR version 4 documentation, you will see that this states that deforestation risk must be examined using the JNR risk mapping tool, and the allocation must be carried out using the JNR allocation tool. However, based on the results from the public consultation that these tools were submitted through, we have been, over the last couple of years, we have been updating these tools and procedures. And this happened very much in relations also with the development of the new consolidated REDD methodology. So what I'm going to do is to describe here how the deforestation risk is assessed and how the FREL is allocated to nested projects and programs, but not using these tools, but using the updated procedures that will be published soon. Now, the updated tool, the latest version of this, is officially called, well, yes, almost officially, it's called VT007, Unplanned Deforestation Risk Mapping and Allocation Tool. And I guess it will become better known by this infamous acronym. I didn't like it. That is it, how it is. So in general terms, the procedure consists of the following steps. First, a benchmark, what we call a benchmark deforestation risk model is constructed. This very simple deforestation risk model basically is based on modeling or assessing deforestation risk in terms of distance to forest edge. It's a well-known observation, very common observation, that areas of those parts that are closer or next to the forest edge are at higher risk of deforestation, and deforestation is less frequent as you go away from the forest edge. In parallel, alternative information richer, perhaps more complex deforestation risk models are also constructed, in which the deforestation risk is modeled in terms of other relevant variables, you know, like distance to roads, distance to human settlements, distance to agricultural fields, and so on, depending on the jurisdiction and conditions operating within the jurisdiction. So what we do is then to statistically compare the performance of the benchmark deforestation risk model with the performance of those alternative, more complex deforestation risk models in purely statistical terms as to their ability to predict the deforestation in the coming years, that is, in the validity period, across the entire jurisdiction. By carrying out this statistical comparison of the benchmark and other alternative deforestation risk models, we would be able to identify the best model, the model that is best able to predict deforestation in the coming years across the entire jurisdiction, not only in particular parts of the jurisdiction, but across the entire jurisdiction. And this model, the best able model, will be then enshrined as a jurisdictional deforestation risk model for this jurisdiction for the validity period. And using this model, we will be able to use this model to allocate proportionally fractions of the jurisdictional FREL to the nested projects or nested programs within the jurisdiction. And one additional advantage of this updated procedure for risk mapping and allocation is that this tool combines, say, the functions of the original JNR risk mapping tool and the JNR allocation tool into a single GIS-based tool instead of two separate documents or tools. So how this works? Basically, is first, the jurisdiction, say this is a jurisdiction, this is the state of Pará in Brazil, if I recall well, the jurisdiction has to be divided into small, what we call modeling regions. These modeling regions have meaning in terms of the spatial and temporal progression of deforestation, and also they display the regional heterogeneity of deforestation processes operating within the jurisdiction, but differently across different parts of the jurisdiction. These modeling regions are constructed from the intersection of two components, literally two maps. On the one hand, first we model the vulnerability to deforestation in terms of the proximity of each point to the forest edge. This graph, for example, shows the amount of deforestation in areas located next to the forest edge and at increasing distances from the forest edge. As you can see, and this is a most common observation, deforestation decreases rapidly with distance to forest edge. And instead of using distance itself, which is a continuous variable, we classify distance to forest edge into 30, what we call, into 30 intervals, what we call 30 vulnerability zones. And we obtain, therefore, a map like this in which we have only 30 different levels of vulnerability in relation to the proximity to the forest edge. The second component is basically using the administrative divisions one level below the jurisdiction. These are for example, in this particular example, these are the municipalities within the state of Pará in Brazil. And the use of these administrative subdivisions is because they represent governmental divisions within which land planning or land use decisions are made. And also, it's very common that the size of each of these administrative subdivisions or municipalities in this case is closely related inversely with the size with population size, population density, and also with the level of human activities. Those small divisions or municipalities are usually the ones in which there are population is larger, population density is higher, and where more human activity occurs. Finally, by overlaying the two maps, the vulnerability zones map onto the municipalities map, we obtain a map of modeling regions. And finally, what we do is simply to tabulate the deforestation, the frequency of deforestation that was observed during the historical reference period within each of these small modeling regions. And by multiplying those data by the activity data estimate, we obtain probabilities of deforestation. And by multiplying by the area of each pixel, what we obtain in the end is a map showing values of the expected density of deforestation per pixel, or in simple terms, the number of hectares that are expected to be deforested in each of these pixels. You know, those pixels in red are the ones in which a higher density of deforestation is expected to occur, and whereas those in darker colors, green or darker colors, are those in which deforestation density is lower. And this actually becomes the benchmark deforestation risk model for this jurisdiction. And this is just a benchmark, an initial reference. It does portray to some extent, or to a good extent, where deforestation is expected to be higher and where deforestation is expected to be lower. This is a prediction of deforestation, of likely deforestation in the coming years. However, it might not be a perfect prediction. Therefore, jurisdictional proponents might wish to consider alternative, more information-richer, more complex deforestation risk models. So what these alternative models can be considered, and basically the idea is, or the procedure would be, construct an alternative information-richer model of vulnerability to deforestation using as many variables as are considered to be relevant for deforestation in this particular jurisdiction. And using the statistical modeling approach that might seem suitable for this sort of data in this jurisdiction. And the predictions of this alternative model must be rescaled to express vulnerability also in 30 ordinal classes, from 1 to 30. And we will simply apply the very same procedure that I just described, but instead of using the distance to forest edge vulnerability model, we will be using the alternative vulnerability maps. And we will end up with an alternative allocated risk model. And finally, what we will have in the end, we will have the benchmark deforestation risk model based only on distance to forest edge, plus one or several alternative risk models that incorporate other relevant variables. And what we will do is then compare in purely statistical terms the performance of both the benchmark and the alternative risk models. And we will be adopting an alternative risk model, any or some of one of the alternative risk models, provided they are better at predicting deforestation risk than the benchmark model, both during the first half of the historical reference period and also using data from the second half of the historical reference period. Any alternative risk model that beats the benchmark model in these two tests can be adopted instead of this benchmark model. And in the end, if we have several alternative risk models, the one that is best of all in these two tests is the one that is adopted for the jurisdiction in the end. And this is how the statistical comparison this is how the predictability of each model, the benchmark of alternative model, is assessed. First, we overimposed a coarse grid of large cells, equal area cells, upon the jurisdiction. The size of these cells is equal to the median REDD project size in this jurisdiction. And then for each of these cells, what we do is to calculate the model, the deforestation predicted by the model, either the benchmark of the alternative risk model, and compare these values with the actual deforestation observed during the historical reference period, the first half or the second half. And we construct a graph like this, in which the x-axis, the horizontal axis, displays the values of observed deforestation in each of these cells, and these are plotted against the deforestation that the model predicts for each of those cells. And these are the values. You see the discrepancies between the predicted and the observed deforestation. If the model were to predict exactly the deforestation in each of these cells, all the data points will align along this red line. And as the farther these points depart from the one-to-one, from this red line, the worse the model is at predicting deforestation. And so with these values, what we do is to calculate the median absolute error of each of these points and add up over all the data points. And basically, the model that yields the lower median absolute error is the best one. And this is an example for Acre in Brazil. This is the plot of observed against predicted deforestation that is predicted by the benchmark deforestation risk model. And this is the graph corresponding to the predictions made by a more complex and multi-layer perceptron model that incorporates 6 different variables, distance to rivers, distance to roads, human settlements, and so on. As you can see, the median absolute error of the benchmark model is higher than the median absolute error of the alternative model, and therefore this alternative model is chosen over the benchmark model for this particular jurisdiction. This is where it is the only alternative model that we are considering. This would be then adopted as the risk model for this jurisdiction. And finally, once we have chosen an deforestation risk model for this jurisdiction, we obtain this map, in which we call it the allocated risk map. And the nice part of this is that you can overimpose the polygon of a project area, and perhaps it's leakage belt or whatever of the project area or program area, and by assuming the values of the pixels contained within this polygon, you obtain the expected deforestation in the project area. And by overlaying a forest stratification map and assigning the emission factors corresponding to each forest stratum and adding, we obtain a map that shows the expected emissions in each of these pixels. And by adding up all the pixel values contained within this polygon, we obtain the emissions that are expected in that project area, which will become the project's baseline. And that would be it. That's basically the process that we will be following for allocating, for splitting the jurisdictional FREL and allocating portions of the jurisdictional FREL to the projects, nested projects and programs. I wonder if you have there are any questions about this. We can take some 5 minutes or so to try to address them. Oh, I see there are
Thank
already
you,
a few.
Salvador. Indeed, there's 3 questions.
Yep. So the first one from Leonardo Sainz. Can peer-reviewed models like LCM, Tercet, or GeoMode by used to create alternative risk models? Yes, for sure. Any alternative risk model can be used, incorporating, of course, incorporating variables that are relevant for deforestation processes. The only requirement to insert this model into this procedure is that the predictions that usually in these models, predictions are usually in terms of probability, 0 to 1 or whatever. These have to be rescaled into a 30 class or 30 ordinal classes. Now, another question is the historical reference period is 10 years or 6 years? Yes, there is a little inconsistency in the JNR. It hasn't been updated for a while, whereas the VCS has been updated much more recently. So the latest VCS requirements state that the historical reference period for these sort of projects should be 10 years, even though the JNR, the previous version of the JNR says that it can be between 6 and 10 years. Yes, calibration will be carried out in the first half of the period and validation in the second half. That's right. Then how many historical years need to be considered for the REL development? That's again, the historical reference period should be 10 years. And can we use Hansen's deforestation or global data? No, we cannot use those data. We have, well, not only we, there are a number of studies showing that those data provide a very good initial approximation to where deforestation, well, not deforestation, tree loss is happening. But if you look at the actual data for a particular location, there are a number of inaccuracies. They are highly inaccurate. They can be used as the basis, but you will have to add to do additional work to come up with an acceptable estimate of activity data. Thank you. I think those are all. Can we take just 5 minutes to change my presentation and running the final one then?
Absolutely, please, Salvador. Thank you. We'll just cross over to the last of the presentations for today, and I think while we're doing that, we'll give the audience a 5-minute body stretch that they can come back again after 5 minutes. So we'll reconvene, let's say, at about 17 minutes past the hour. Thank you.
Thank you so much. See you.
Okay, Salvador, we are now 17 minutes past the hour. Shall we proceed then? I see there's one question before we delve into the last presentation of the day. There's a question here which says global allometric equation is available in the RPCC 2006 GL. Can we use this unless we have it?
Oh, sorry, I need to share my screen, right?
Sure, thank you.
No, we are
Yes.
right. Done. So global allometric equations are available in the IPCC. Can we use these? Yes, global models can be used under certain. No, the JNR framework and the BCS requirements include provisions for using models developed elsewhere or even global models, provided they meet some accuracy requirements. In those cases in which field data or locally developed allometric equations are not available, yes, some allometric equations that are developed elsewhere or even global models can be used, but provided they meet the requirements stated in the BCS requirements for the use of models. Thank you.
Perfect. Thank you so much, Salvador. So thank you also for returning after the short body break. This is then, as I mentioned, the last presentation of the day and of the two sessions focusing on the VCS JNR framework. Can we jump to the second slide, please, Salvador? I'm going to hand back to you again to take us then through the agenda of this specific presentation. Thank you.
Yep. Thank you, Leo. So in this last segment, the end of the season, I will first outline briefly two essential elements of the JNR program: leakage and not only a JNR program, but any REDD project or program, which are leakage and the risk of non-permanence. Then I will outline the JNR requirements or guidelines that must be applied for monitoring the program performance, and also, more importantly, perhaps, for quantifying the emissions reductions that are achieved by a project, by a JNR program. Now, each of these four elements or activities involve a number of specific considerations and details and provisions that have to be taken into account, but it would take us too long to discuss here, and we cannot simply describe them here. But I encourage all the participants to review in detail these topics in the JNR requirement documents, please, because it's really, there are a number of details on particular situations in which some action or some other action should be taken. So I will just provide a brief, very superficial overview of these topics. So first, leakage. We are all familiar with the concept of leakage. In this particular context, we would be looking at the possibility or the risk that a project successfully reduces or avoids deforestation within its project area, but as a consequence of this, deforestation or forest degradation continue occurring, but in some other part. So in the case of a scenario 1 program, we should be looking at the possibility that deforestation or forest degradation is displaced from the project's areas themselves to other locations, either within the jurisdiction or even outside the jurisdiction onto neighboring jurisdictions or even neighboring countries. By contrast, in a scenario 2 program, we are not very much concerned about the risk of deforestation or forest degradation being displaced from a project area onto another location within the same jurisdiction, because we will be conducting monitoring across the entire jurisdiction and projects, and so this leakage will be sort of taken into consideration anyways. What we will be looking at here in both in scenario 2 and scenario 3 is the possibility of the risk of deforestation or forest degradation being displaced outside beyond the jurisdictional boundaries into other jurisdictions, neighboring jurisdictions, or even other countries in both cases. So how we take leakage into account? First, at the jurisdictional level, at the level of the jurisdictional program. In scenario 1, there are no requirements because there are no crediting and no GHG emissions reductions properly at the jurisdictional level, only at the level of the projects or the nested projects or programs. In scenario 2 or scenario 3, we have to look at the jurisdiction, at the leakage at the jurisdictional level. In this case, all scenario 2 or 3 programs must consider the 3 types of leakage that are described or are included in the VCS methodology requirements. Leakage due to the displacement of activities into other areas, leakage due to changes in the market conditions, and ecological leakage. Leakage that happens outside the country, that this international leakage, does not need to be accounted for nor deducted from the jurisdictional or from the GHG emission reductions that are achieved by the jurisdictional program. And unfortunately, but for conservative reasons, positive leakage is not to be accounted for. That is, those cases in which, for example, a project decreases deforestation in its project area, but also as a consequence of the interventions included or implemented by this project, deforestation is not displaced to other areas, but on the contrary, deforestation in the neighboring areas is also reduced. That's a sort of leakage, what you call positive leakage. You know, that the benefits of the interventions in the project somehow spur beyond the project area boundaries onto neighboring areas. Unfortunately, but for conservative reasons, this positive leakage is not taken into account. Now, so one important point is where the jurisdiction contains or includes non-forested wetlands, including peatlands, the program must identify the potential for leakage from forested wetlands onto non-forested wetlands. That is where the GHG emissions increase or removal increase. In those cases in which GHG emissions increase or removals increase from forest wetlands should be mitigated, and procedures should be implemented to account for this leakage into wetlands or non-forested wetlands. Now, in a scenario 2 or 3 programs at the jurisdictional level, first, what we have to do is the jurisdictional proponent must identify the drivers of deforestation or forest degradation and how likely they are, or what their potential for each of these drivers of deforestation or forest degradation are for leading to leakage, to be displaced to some other areas or so. And for each of those drivers of deforestation or risks of leakage, the program should design and implement some measures aimed at mitigating or reducing the risk of leakage. Any remaining leakage, or the leakage that happens despite the implementation of these leakage prevention measures, have to be accounted for. And leakage can be accounted by using any one or even several of these methods. For example, a leakage belt for monitoring and accounting leakage can be established or defined outside outside the perimeter of the jurisdiction. There is also the JNR framework also has a JNR leakage tool which provides a number of guidelines and procedures for identifying and accounting for various types of leakage. And finally, we can also identify and monitor activities that were not included in the jurisdictional FRAIL, for example, forest degradation, but that are at risk of causing leakage. Perhaps the FRAIL only includes deforestation, and activities are implemented in the project in order to reduce deforestation, and they might reduce deforestation, but instead they might increase the forest degradation. So that sort of activities should be identified and monitored to account for leakage properly, or as much as possible. Any leakage that is estimated or is observed to occur using either of or a combination of these three tools, then must be subtracted from the GHG emissions reductions that are achieved by the jurisdictional program. Now, how do we identify and account for leakage at the level of the nested projects and lower level programs? In a scenario 1 or 2, in which we have properly nested projects and programs, basically what we have to do is these projects have to apply all the requirements and procedures that are set out in the VCS standard and those that are included in the particular methodology that is used in these projects. And yeah, the lower level programs must follow the requirements that we are just describing, and they are fully detailed in the JNR requirements. Now, another consideration that is really important is considering the risk of non-permanence. You know, the risk that those activities that were implemented by a REDD project remain in place, but for some reason, while they remain in place, they successfully reduce deforestation, conserve the forest, and so on. But for some reason, at some point in time, these interventions fail or cease to exist, and therefore the carbon that was stored in the various or different carbon pools in the forest is at risk of being released back into the atmosphere. For example, when some natural or anthropogenic events affect the project area and then destroy the forest, and then the carbon that was stored in the various carbon pools of the forest and that had been protected by the project interventions are at risk of being released again into the atmosphere. So this risk has to be identified and accounted for, and as we will see, somehow included into the project performance. So in a scenario 1, we will be looking at the risk of non-permanence in the nested projects and lower level programs within the jurisdiction. Whereas in scenario 2 program, we will be looking at the risk of non-permanence at the jurisdictional level, at the programs at the jurisdictional program level, but also at the project and lower level programs level. You know, non-permanence might occur either in the entire jurisdiction or might affect interventions that were implemented through the jurisdictional program, or the local level interventions that were implemented by each of these projects. Finally, in a scenario 3 program, we will be looking only at the risk of non-permanence of those interventions that are implemented by the jurisdictional program across the entire jurisdiction. And the JNR, the VCS in general provides 2 tools by using which we can identify and somehow assess or evaluate the risk of non-permanence, which is the risk analysis tool, and also how to account for that risk by constructing and adding credits to what we call the pooled buffer account of the VCS. First, how we identify and account the risk of non-permanence at the level of the jurisdictional program. As we said, in scenario 1, there is no, we do not assess the risk at the jurisdictional level because there is no jurisdictional level program, but we have to do that at in the scenario 2 or scenario 3 programs. First, what we do is to assess the risk of non-permanence at the jurisdictional level using the JNR non-permanence risk tool at each verification event. The results from this analysis have to be reported to Verra using the report template of the JNR non-permanence risk, and the results of this included in this report should be assessed by the VVV. And the most important part is that a number of credits, we call them buffer credits, are deposited from the program into the jurisdictional buffer account. And these buffer credits become stuck in there, in the jurisdictional buffer account. They do not become VCUs, cannot be traded, sold, or exchanged. And in the case of carbon losses, a fraction or a number, the corresponding number of buffer credits have to be canceled out. Now, however, those jurisdictional programs that demonstrate that they are able, or the interventions in the jurisdictional program are sufficient to mitigate the risk of non-permanence, and that they have demonstrated their long-term longevity and sustainability, then eventually they can have a number or a portion of the buffer credits that have been stored or kept in the jurisdictional buffer account can be eventually released and issued as VCUs. There are a number of considerations for doing this, and these are described in the JNR registration and issuance process document. Now, in the case a loss event occurs, the jurisdictional proponent must, this is a loss event at the level of the jurisdictional program, at the jurisdictional level. In those cases, the proponent must notify Verra within 6 months of discovering or having noticed the forest loss event, and then submit a loss event report quantifying the impact of this loss event. This must be reported to the Verra registry within 2 years of discovering the event. When the time comes for the next monitoring report, these forest losses are restated, and the net GHG benefits recalculated by basically discounting the credits, the corresponding GHG emissions that were lost due to this event. Now, how we identify and quantify and account for the risk of non-permanence in those projects and lower level programs nested within a jurisdictional program. This happens in the scenario 1 and scenario 2 only, because in scenario 3 we don't have nested projects. And this is pretty straightforward. All the nested projects must follow the requirements set out in the VCS standard for non-permanence risk. And the procedure in general is very straightforward. Each project, or for each project or lower level program, a risk analysis has to be conducted using either the AFOLU non-permanence risk tools in the case of individual projects, or the JNR non-permanence risk tool in the case of those lower level nested programs. And the number of credits that have that are result from this risk analysis have to be deposited into the jurisdictional buffer account. Again, these buffer credits that are deposited into the jurisdictional buffer account become sort of stuck or frozen in there, cannot be issued as VCUs, cannot be traded or sold, and event in the case of an eventual carbon loss, they have to be canceled out. Now, coming to monitoring. First, what we will be, in the JNR context, monitoring refers to periodically collecting and analyzing data to evaluate the performance of the JNR program or its nested projects. In this context, the performance of a JNR programs is expressed in terms of the GHG emissions reductions that the program or its projects achieve through their interventions. And particularly in a scenario 1 program, what we will be evaluating is the remember that in a scenario 1 case, we don't have a jurisdictional program. We only have nested projects and lower level programs. So what we will be looking in monitoring is evaluating the performance of the nested projects of these projects and the lower level jurisdictional programs. By contrast, in a scenario 2 program, we will be evaluating the emission reductions that were achieved by both the jurisdictional program and also by each of those nested projects and nested lower level programs. And finally, in the scenario 3 program, we will be only evaluating the performance of the jurisdictional program as a whole. You know, the emission reductions that were achieved by the jurisdictional program in its entirety. We won't be looking at the performance of each of these local level interventions, but only what happens at the jurisdictional level as a whole. So these are the requirements for monitoring at the jurisdictional level. First, all the activities and carbon pools that were included in the project or program descriptions should be monitored and using the same methods that were used to set the FREL, to construct the FREL. Second, the entire forested area of the jurisdiction, except for those areas that are allowed to be excluded, must be monitored. All the forested area in the jurisdiction must be monitored. And monitoring must be carried out at least every 2 years. And the monitoring periods should be contiguous. There should be no gaps or overlaps between monitoring periods so that in the aggregate, all the monitoring periods encompass the entirety of the crediting period for all the nested projects and lower level programs that are included within the program. Then the results from the monitoring should be reported using the JNR monitoring report template. And these results from the monitoring results should be validated or verified. In the case of scenario 1 program, monitoring data must be validated by a VBB at least during when the FEL is to be updated, whereas in a scenario 2 and 3, monitoring data must be verified at least once during each validity period. Now, the common requirements for monitoring the performance of nested projects and programs are as follows. First, the results, monitoring results that are obtained in the monitoring of the projects and lower level programs can be incorporated into the jurisdictional level or the program level monitoring. In those cases where, as is common the case, that projects or lower level programs are able to obtain more accurate estimates of the emission factors, these can be incorporated into the jurisdictional FREL, the jurisdictional program. And finally, monitoring the performance of nested projects is pretty straightforward. They should follow the monitoring requirements and guidelines that are set out in the methodology that was used for these particular projects. Now, in a scenario 1 program in which we have a jurisdictional program, we don't have a jurisdictional program, but we only have nested projects and lower level programs, the results or the data that were used to reassess the jurisdictional FREL can be used or can be incorporated into the monitoring of the performance of the nested projects and programs. And in scenario 2, program displays a more complex or a number of possibilities, different possibilities, some of which are more complex than the others. For example, where the jurisdiction and the nested projects utilize the very same data and very same methods to estimate the emission reductions, the emission reductions achieved by the program, the jurisdictional program, and by the projects, then the results from the monitoring results from the projects can be incorporated and used directly for monitoring the jurisdictional program. And there are no discrepancies between these two estimates. However, it's often the case that the projects utilize different data, typically higher resolution data and perhaps more accurate methods to estimate their emission reductions at the project level, whereas the jurisdictional program utilizes different methods and perhaps coarser resolution data. And therefore, in those cases, the emission reductions estimated at the jurisdictional level might show discrepancies with those that are estimated at the project level. That might be the case. However, in the project description, in the JNR program description, should include a number of provisions on how to address these discrepancies, and more importantly, how to reconcile those discrepancies in case they arise. And there are, the program description should include those provisions, and therefore, at the end of the monitoring process, this reconciliation should be carried out. The point is, or the important point is that if as a result of the reconciliation process, we obtain a negative amount of emissions reductions, that is, that emissions reductions achieved by the program and its nested projects were overestimated, then if this overestimation was identified after VCUs had been issued, then this should be considered as reversals, and these will be discounted or made up for in the next monitoring report period. Now, an important consideration is that the nested projects and lower level programs nested within a scenario 2 program can monitor and verify the results, and therefore request credits to be issued at different times or different intervals that the jurisdictional level program, because they might have started at different dates, and they might request monitoring and credit issuance at different times. But these are subject, of course, at reconciliation between the levels. And finally, perhaps the most important part is quantifying the GHG emission reductions that are achieved by the REDD activities, the jurisdictional REDD programs or nested projects within projects. In general, the net emission reductions that are achieved by REDD activities, that's the important part, are the basis for estimating or calculating the volume, the number of VCUs that can be issued to the REDD activity, the REDD program, or the REDD project. Now, in general, the net GHG, the net emission reductions are determined as the difference between the emissions, estimated emissions in the baseline scenario without the project, and the emissions that occur during the project or the program scenario. Now, in the scenario 1 program, we will be looking, as there is no jurisdictional program, we will be looking at the net emission reductions that are achieved only by the nested projects and the lower level programs. And based on this, we will be able to determine the number of VCUs that can be issued to those nested projects and lower level programs. Whereas in scenario 2, the emission reductions, we will be looking at the emission reductions that are achieved both at the jurisdictional level, by the jurisdictional program at the jurisdictional level, but also those emission reductions that are achieved by the nested projects and lower level programs. And based on these results, we will determine the number of VCUs that can be used to both the jurisdictional program and its nested projects or programs. And finally, in a scenario 3 program, we will be looking at the emission reductions that are achieved only by the entirety of the jurisdictional program, and this will be the basis for determining the number of VCUs that can be issued to the jurisdictional program in its entirety. Now, how we quantify GHG emissions reductions at the jurisdictional program level. So the net emission reductions attained and that are achieved by the jurisdictional program, and in scenario 1, there are no jurisdictional programs, so we are not quantifying emissions reductions in this case. But we quantify emissions reductions attained by the jurisdictional program in a scenario 2 or scenario 3 programs. In this case, we first estimate the emission reductions in general as simply as the difference between the jurisdictional threshold, the emissions that would occur in the baseline scenario, minus, or we deduct from this the emissions that occur during the project or program, during the program implementation. The difference between these two quantities represent the emission reductions that are the overall emission reductions that were achieved by the jurisdictional program. However, we must deduct from these emission reductions those that were displaced somewhere else in the form of leakage. And this, by deducting the leakage emissions from the GHG emissions reductions, we obtain the net emissions reductions achieved by the program at the jurisdictional level. This has to be done separately for each stratum and for each activity, deforestation and separately from the forest degradation. Based on this, we can determine the number of VCUs that can be issued to the jurisdictional program. In the case of the scenario 2, the number of credits that can be issued to the jurisdictional program will be determined by subtracting from the net GHG emission reductions that we just calculated, the number of credits that have to be deposited into the pooled account to make provision for the risk of non-permanence. And also, we will have to deduct the emission reductions that are issued to the nested projects and programs. In a scenario 3, in contrast, in a scenario 3 program in which we don't have nested projects or programs, the number of credits that can be issued to the jurisdictional program is simply determined by deducting from the net GHG, the net emission reductions achieved by the program. We have to deduct from the net emission reductions achieved by the program the number of credits that have to be deposited in the pooled account to make allowance for the risk of non-permanence. Now, how we quantify GHG, the emission reductions that are achieved by the projects and lower level programs in a scenario 2 or a scenario 1 or a scenario 2 case. First, the net emission reductions that were attained by the nested projects or the lower level jurisdictional programs can be determined first by determining the emission reductions, simply deducting by discounting simply as the difference between the baseline, the emissions that would occur in the absence of the project, minus the emissions that actually happen during the project implementation. And this will yield the emission reductions achieved by the program, however, by the project or jurisdictional or lower level program. From these emission reductions, we have to deduct the emissions that were displayed somewhere else in the form of leakage to obtain the net emission reductions achieved by each of these nested projects. And finally, the number of credits that can be issued to nested projects of nested lower level programs can be determined very simply by deducting from the net emission reductions the number of credits that have to be deposited in the pooled account, or in the case of lower level programs, we have to deduct from the net emission reductions the number of buffer credits and the emission reductions that are issued to the nested projects. And that will yield the number of credits that can be issued to the nested projects or the nested lower level programs. Of course, in the scenario 3 case, we don't have nested projects nor lower level programs, and that's it. Finally, all these estimates, again, are based in a number of estimations and statistical procedures and calculations, all of which involve the various sources of uncertainty. And therefore, for conservative reasons, the emissions reductions that achieved by the program, or the estimated emission reductions achieved by the project or programs, have to be conservatively deducted, discounted based on their uncertainty, utilizing the very same formula that we saw and the very same levels. The higher the uncertainty of those estimates, the larger the discounting that has to be applied. And I think that is it. Basically, yes, and we still have a few minutes to try to address some questions that you might have on this regard. Again, all these processes and or considerations that I just described in this last presentation involve a number of particular cases, particular considerations, and guidelines that it would be too long to describe here, but are fully described in the JNR requirements. So I encourage all of the participants to look at those documents in detail, please. So, but if there is any question that we can address here, I'm very happy to try to respond.
Absolutely. Thank you so much, Salvador. I do welcome participants to raise your hand if you have any questions to ask that question live. We'll make that available at this point. Also, if you have a question you'd like to post to the chat, you can do the same. And also on the last slide of this presentation, we will again share the email address for Salvador. Should you have a specific question you'd like to raise directly with him, that you can do. While we're on this slide, thank you, Salvador. While we're on this slide, the previous slide, can we jump back to the previous slide, Salvador, while I'll give the participants an opportunity to think of, I'll give them opportunity to think of any questions they may have. So
yeah.
While I have your ear as VVBs, I'd like to take the opportunity to make you aware of our next upcoming training dedicated to VVBs, and the training is scheduled for the 21st of November, and the topic of that training is going to be looking at additionality and regulatory surplus. So if you can click once, I'm going to just give participants the QR code. There we go. So here is the QR code for the upcoming training on the 21st of November. You're welcome if you'd like to scan this QR code and register for the session. We will also be sending out the invites to the main contact detail or contact person at our VCS approved VVBs. So back to the questions for the JNR program. Salvador, if you would like to go to the next slide, which has your contact details. I would like to encourage participants, if you have any specific questions that you'd like to address with Salvador, his email address is at the bottom of the slide. Please write to him directly. I don't see any questions, Salvador, in the Q&A function at this point. So I think then we will, given being cognizant of the time, I think you've done an excellent job in keeping us within the time frame. So thank you for that. I'd like to thank you, Salvador, for a wonderful presentation, and I know it's a very complex matter, JNR, and as you said, it would be good for our participants to go through the JNR requirements document in detail to get a full scope of what it entails. And I do thank you for shedding light on this matter and encouraging our VVBs to consider pursuing auditing of JNR projects and programs as well. So that being said, I thank the participants for their time and for attending this training. We will be sending out a recording of the session 1, part 1, as well as part 2, together with the slide deck. And as indicated, this is a training session which assists VVBs in meeting the eligibility requirements for auditing of JNR projects. Therefore, there will be also a brief test that will be accompanying the recording of the presentations and the slide deck, and we would encourage participants to complete that to prove knowledge has been absorbed from these training sessions. So we thank you for your time, Salvador. Thank you so much for a great presentation, and we wish you all a wonderful day further wherever you are. Thank you.
I would also like to thank all the participants for taking the time to attend to this. I hope you found these presentations informative, reasonably clear, and there are too many details. The JNR framework is pretty complex. There is abundant documentation with many details that you have to look. I will encourage you to look at them in the documentation, and also as I said in the very first session, there has been no JNR program implemented yet. So many of these things are, described in the documents and the guidance and so on. But in practice, a number of things might still come up, when we have the opportunity to implement a JNR program, and you will have the opportunity to audit one of the implementation of one of those programs, and hopefully the results achieved by some of those JNR programs in the coming future. So please bear with us. There are a number of things, a complex matter, and there are a number of things that are still to be tested in the field. But for the time being, thank you so much for your attention and for taking the time. And please have a closer look in detail at the documentation for the JNR. Thank you so much. And thank you, Leo, for all the support and for facilitating all the logistics.
Thank you so much.
Until
Thank you,
then.
Salvador.
Bye.
Cheers.